Section 3.2, graphs of functions. Our objectives are to determine if a graph is a function, analyze graphs to determine domain and range, maxima and minima, inflection points, and intervals where they are increasing, decreasing, concave up, and concave down. Now, we might not get to all that in this video, but we will eventually get to all of it. For the first part, we're just talking about graphs of functions. Functions are defined by graphs. A graph may be used to define a function or a relation. Remember, if it is a function, graphs that are functions pass the vertical line test, which we'll talk about in a little bit. Now, for this, we're going to use the graph to answer these questions. For f of 0, I look at an x value of 0, what is my y value, which would be right here, at 8. So f of 0 is 8. At f of 3, so an x value of 3, I have a y value of 1. Then my domain remembers all my possible x values. Because I have this arrow on the end of my graph, I know my x values are going to continue to get larger and larger in the negative direction. And then here I have an open circle here and here. That means at an x value of 1, there are no y values defined. So we're going to leave our graph with the open circle when we write our domain. And then here, it goes all the way up to 7 in an open circle because we're not including 7 as well. So remember, when you're not including points, you use parentheses. So parentheses negative infinity, 2, in this case we have 1, parentheses union, parentheses 1 to 7, parentheses, again, because we're not including the point 1 because there's no y value, x values defined at that point. And at 7, same thing. Now for the range, again, it goes down to negative infinity. We have an open circle here, but it's taken care of with this y value. We also have an open circle at this place, but it's taken care of there, and this one's taken care of. So our graph goes all the way up to 8, and we don't have any breaks in our graph all the way up there for our y values. So then my range would be negative infinity to 8 bracket, because now we're including the point. Now for these next ones that you have, I want you guys to do example A, B, and C. So you do these. And then, of course, we'll go over those tomorrow. For the next part, we're going to talk about the vertical line test. So hopefully by now you guys know what the vertical line test is. So just as a reminder, a graph in a coordinate plane represents a function if and only if no vertical line intersects the graph more than once. If we look at this first graph that we have, notice that this would not pass the vertical line test. Therefore, this is not going to be a function because pretty much almost everywhere you put the line, it intersects in two places. So like right here, it would be intersecting here and here. So we know this is not a function. Now, I want you guys to do B, C, and D on your own. For the next part, we're going to talk about analyzing graphs. So all these 5 steps that we have right here are what we're going to be eventually doing. So the x and y intercepts, interval where the graph is increasing or decreasing, local maxima and minimum, intervals where the graph is concave up or concave down, and we're going to talk about points of inflection. Hopefully you remember from previous classes when you are talking about the x and y intercept, to find the x-intercept, remember it's when you plug 0 in for y, and then solve for x. And for the y-intercept, you plug 0 into x and solve for y. And for these, of course, you can also look on your graph, the x-intercept where it crosses the x-axis, the y-intercepts where it crosses the y-axis, of course. Now we're going to talk about some new stuff. We're going to talk about increasing and decreasing functions. Increasing is on the interval of the graph is always rising as you move from left to right. If you're decreasing, it's the graph y values are falling as you move left to right, and constant if you have a horizontal line over the interval. For these, it's really important that you remember we are using the x values for the intervals. So when you're using the x values for these intervals, we don't want to get it confused with domain and range because we use interval notation for that too. So you have to write whether or not it's increasing or decreasing, otherwise you wouldn't know what you were talking about. So remember that these are not points, that these are intervals. So for this first graph, again, we're going to look as our x values are moving from left to right. So as our x values are increasing, what are our y values doing? So it usually helps me to just kind of think of a line. So as I move this line that I have here from left to right, so as my x values are increasing, your y values are doing two different things. Notice that for this first part, our y values are decreasing until you get to about this point right here. So for my interval that I'm going to write, I would write from negative infinity to this x value point right here, we are decreasing. So I have to figure out what that value is. If I have the equation, I can use my graphing calculator to find the minimum value. If I don't, I can just look at the graph that I have. So in this case, it looks like negative 5, 6. So this is an x value of negative 7. So that means that we are decreasing on the interval from negative infinity to negative 7 and parentheses. For increasing and decreasing, we are going to use parentheses for that value because at the maximum or minimum point, it's the point where your graph is changing. And since that's the point where your graph is changing, we don't include it because we don't say that it's increasing nor is it decreasing at that value. Then the next part of this graph, if we keep on going from that value on, notice that as your x values are increasing, your y values are increasing. So then I would write increasing on the interval from negative 7 to positive infinity. And again, we're not including negative 7 because that's the value of which your point is changing from increasing to decreasing. If we look at the next graph that we have, for this next graph, you're going to do the same thing. So as I move from left to right on my graph, so as my x values are increasing, what are my y values doing? Now notice that your y values appear to be increasing over the entire interval. It's hard to tell what's happening right around here in the middle, but to me it appears that they are increasing. So if that's the case, then you can just say that your graph is increasing for all real numbers, so it would be the interval from negative infinity to infinity. If we, let's say, had a graph that went this way, like that, then that would be considered decreasing from negative infinity to infinity. And again, you have to write whether or not it's increasing or decreasing. And for this last graph, as we move from left to right, our y values are staying constant, so of course this would be constant. And the interval from which we are constant would be negative infinity to infinity. All right, so let's go ahead and look at this graph. So it says on what intervals is the function increasing, decreasing, or constant? So again, if you think about moving from left to right on your graph, as I move from left to right, what are your y values doing? So as we move all the way to about an x value right here of 0, notice that your y values are decreasing. So the first interval would be decreasing. And we're decreasing from negative infinity to an x value of 0. And again, not including 0 because that's the point where we're changing over. And for this, then the next part we have from 0 all the way to an x value of 2. Notice that we are constant, so the next part would be constant. And we are constant on the interval from 0 to 2. Now, constant intervals are different because when you're constant, we do use brackets to include the point because we're saying starting at that value to the next value, you can be equal to that. So that's why we're going to use brackets. Constants are the only ones. Decreasing, increasing, we'll always use parentheses, whereas constant, unless it's constant from negative infinity to infinity like the last graph, we will use brackets. So then the next part that we have on our graph from an x value of 2, moving on, our y values are increasing. And we're increasing from the interval parenthesis 2 to infinity, parenthesis. And again, yes, you do have to write decreasing, increasing, or constant for whatever values that you have. And again, notice that I use the x values and not the y values when I was doing this. For the next part, these graphs that we have right here, I want you guys to do these graphs and I want you to determine if it's increasing, decreasing, or constant, and I also want you to practice doing the domain and range, and then we will talk about these graphs later. So if you can bring those with you to class. For the next part, we're talking about local maxima and minima, which is just plural for maximum and minimum. For this, these are the peaks and valleys of the functions of the graph. They're the turning points for where the graph shifts from increasing to decreasing, or vice versa, as I said before. A function has a local maximum if that point that you have, so here and here, if every point surrounding it is lower than that point. So notice that the points to the left or right of those green dots that I just put there are lower than that point, so that means these are the peaks, or we call them local maximum. Sometimes you'll also see relative maximum. Local and relative just mean the same thing. It just means that at those points it's relatively, or the highest maximum point. However, if you notice over here, because your graph goes all the way up to infinity, we know that it's not the actual highest point on your graph. Same thing with these points down here. Here and here we have relative minimum, or you can say local minimum. And for that, it's because relative to the points around it, they are the lowest points. However, because your graph continues to go down to negative infinity, it's not the actual lowest point. Now, if we had a graph that was something like this, a parabola, this point on our graph would be called the absolute minimum, because nothing else on our graph is lower than that point. So it is the absolute minimum, whereas if I had maybe a graph that looked like this, I would call this point right here the absolute maximum. It's not relative anymore because it's the highest point on our graph. This would be the relative or local maximum point, because relative to the points around it, it's the highest, but however, this point over here is at the actual highest. Now, when you're doing these graphs that you're going to be given, you're going to have to find the maximum and minimum in order to tell your intervals where you're increasing and decreasing. So we're going to practice this example A that we have right here. It says, find all the local maximum and minimum increasing and decreasing intervals and the x and y intercepts. So basically we're trying to evaluate everything we possibly can for this function. So the first thing you want to do in order to do these problems, you're going to want your graphing calculator. So you guys should get out your graphing calculator, and of course you're going to want to follow along the steps so that you are practicing, so that you know how to do them when you are doing these problems. So the first thing you want to do is go to your y equals and plug in the function, which I already have in there. So that's what you guys want to do first. Then I always like to hit zoom 6 because it's a standard window, and kind of check out what's happening at my graph. So this is what my graph looks like. Now, if I look around this middle section, I'm having a hard time determining what is going on there. So what I'm going to do is I'm actually going to zoom in a little bit closer around that point. So when you do that, if you just hit enter, it'll zoom in. And now you can see, well, it's a good thing we did that because I have a local maximum and a local minimum. So I have this point here and this point here that I need to find. So that's the first thing I'm going to do. Now, in order to do that, what you want is to go to second, trace, and if you go to, we're going to do the minimum first, enter. Now you see you have your value here. So you want to take your cursor and go to where you think, which is right here where it's flashing, the local minimum is. And notice it says left bound here, so you want to go a little bit to the left of that point. It doesn't exactly really matter where, as long as it's somewhere to the left, and hit enter. And notice that it gives you this arrow that we've talked about before, because your graphing calculator is going to guess in between the arrows. So now if you go to the point again and then go somewhere to the right of the point and hit enter, then notice you get this arrow here. So as long as your value's in between, then you know when you hit enter for guess, it's going to give you that value. So now I have the value. And it tells me that my minimum, and for this, because it's a minimum point, we're actually going to write down the x and y value. So for this, we have negative 0.5773, comma, negative 0.3849. So I always like to round to 4 decimals. And now I'm going to do the same thing, except for now I need to figure out the maximum. So now I'm going to do number 4. And I'm going to scroll my cursor over to where I think the maximum is. Then I want to do something to the left of that, enter. Go back to where the maximum is and then go somewhere to the right and hit enter, and then enter for guess. And when I do that, I get my maximum. Point at 0.5774, I'm rounding because we have 3 and then a 5 after the 3, comma, 0.3849. So that would be my minimum and my maximum points that we have. Now that I have the maximum and minimum points, I can figure out the intervals for where we are increasing, decreasing, and or constant. Obviously for this graph we have no values of which we are going to be constant. So if you look from left to right on your graph, so as your x values are increasing, notice that when we get to this value right here, our y values are decreasing. And then at that point, from there to this next part here, notice we are increasing, and then for this last part we are decreasing. So when you're doing this, that's why it's important to find your maximum and minimum points first, because then if you don't, you can't really tell the intervals where you're increasing, decreasing, and constant. So for this, I'm going to go ahead and do the first part, which is decreasing. So I'm decreasing from the interval negative infinity, comma, and notice this is, you're using your x values, so the x value of your minimum is negative 0.5773, parenthesis, because remember for increasing and decreasing, that's the point where it's changing, so we don't use brackets. And then from that same point now to this point here, we are increasing, so then I'm increasing on the interval from negative 0.5773, comma, to, and then now I need to look at the maximum x value, which is this one right here, 0.5774. And then for the last part, I am again decreasing on the interval from now this value, which we just wrote, 0.5774, because that's the x value of the maximum, to infinity. And that would be for my minimum, maximum, and for my intervals where I'm increasing and decreasing. If you want to write the decreasing interval altogether, you can. I prefer to write it like this because that way I don't miss anything on my graph. I put this on my paper, and then the next thing we need to find is the x and y intercept. So remember, if you want to find the x-intercept, you plug 0 in for y and solve, and to find the y-intercept, you plug 0 in for x and solve. Because we're given the equation, it's easy to find the y-intercept. So for the y-intercept, if you plug 0 in for x, so we have negative 0 cubed plus 0, notice I would get 0. So my y-intercept, and you can even look at your graph and see it's right there, your y-intercept would be 0, 0. Now I also need to find the x-intercept, and for the x-intercept, notice I have 3 different values for my x-intercept. I have an x-intercept here, here, and here, so I'm going to use my graphing calculator to help me find the x-intercepts. On my graphing calculator, I can also find my y-intercept by doing second trace and value. if I put in a value of 0 for x, notice that you get a y value of 0, so we know that's one of our x-intercepts as well. We need to find this 0 and this one here, so we learned how to do that by doing second trace 0, and so I'm going to scroll over here and do something to the left, enter, something to the right of that value, enter, and then enter. So I get -1. So x equals -1, 0, because that was this point right here. And now we need to do the last x-intercept. So second trace, we're going to do the 0 and scroll all the way to the other side of my graph. And left bound would be something over here, enter. Something to the right would have to be below the x-axis, enter. And notice that for when I'm guessing, it's these arrows right here and here in between where I think it is, and enter. So I have an x value of -1, 0, and 1. So then my x-intercepts are going to be x equals -1, 0, and 1. And if you want for the y-intercepts, you can also just write y equals 0, that's fine. And that's everything that we need so far. So let's go ahead and practice B. For B, you're going to do the same thing. So what I would do is I would pause the video, see if you can do it on your own, and then unpause it, and I'm going to put up the solutions. I plugged it into my y equals on my graphing calculator. Then after you plug it into your y equals on your calculator, you're going to hit zoom 6 for a nice standard window. And when I'm looking at this graph, it's hard to tell what's going on here in the middle, so I'm going to hit zoom, and if I zoom in around that area, and use my cursor to move so I can zoom in here, and hit enter on the place where you want to zoom in, this is what my graph then looks like. Now, I can't tell if I have a maximum or minimum, so what you can do is if you hit trace on your graph, and I'm going to start over here. If I hit trace on my graph, I'm going to look at my y values to see if they're increasing the entire way or if at some place one of the values is lower. So notice that 1.15 is my y value now, and I have 1.16, 1.17, and it keeps to seemingly increase. And then notice from here, this point that we just had to this point, notice that it's a lower y value. Therefore, when that happens, that means you do have a maximum and minimum value. It's just very difficult to tell. So again, what I did was I used my trace feature on my calculator, and then I just scrolled from left to right and just looked at my y values to tell whether or not I had a maximum or minimum value. Now that I know that I do, second trace, I'm going to do the maximum first because that comes first. So maximum. The maximum must be somewhere around here. So I'm just going to scroll somewhere to the left, hit enter, and somewhere to the right, about that same value, enter, and then enter. So it looks like we have a maximum value right here. So maximum would be 0.4367, comma 1.1767. And then I'm going to do the same thing for the minimum. So second trace minimum would be number 3. And so I'm going to just go from that same value. I'm just going to go from here over to here, enter, enter, because I know it's somewhere in there. And notice I get a minimum of 0.7633, comma 1.159, and I'm going to round that to a 3. So that would be my minimum. So I should have marked my maximum. So that's my minimum. My maximum was somewhere over here. So that means from left to right as I'm moving, so from here to here, I am going to be increasing on my graph. So I'm increasing from the negative infinity to the x value of my maximum, which we already wrote down was 0.4367. And then I'm decreasing on the next interval from here to my minimum. So I'm decreasing from 0.4367, the x value of my maximum, to the x value of my minimum, which is 0.7633. Then the next part, I am going to be increasing again. So I'm increasing so increasing from 0.7633 to infinity, I am, again, from here to here, going to be increasing. So those would be my intervals. The next thing I need to find is my x and y intercept. So for my x-intercept, I can use the 0 method, and it looks like I only have one x-intercept right here. So second trace number 2, and I'm going to scroll. Something to the left of that 0 would be below the x-axis. Enter, and something to the right would be above, enter, enter. So my x-intercept would be, or my 0 would be, x equals negative 0.4784, and my y-intercept, I can plug 0 into my equation and figure out what my y-intercept is, or I can hit, whoops, if I go to second trace and I want the value, which is number 1. If I hit an x value of 0, because that's what I'm doing, I'm plugging 0 into my graph, I get a y value of 1. So I know my y-intercept is going to be 0, 1, or you can y equals 1. So that's all the information. And now I have analyzed everything I need for the graph. So we're going to stop there, and for the next video we'll talk about concavity and points of inflections, and also we're going to graph some more piecewise defined functions. So make sure again that you do those problems that I did not do and have those ready for class.